Section 6.4, adding and subtracting radicals. Just a couple things that you need to know right off the bat. First off, you need the same index if you're adding two radicals. And just to let you know what an index is, if you've got a radical sign like that, the index is the number that's located in the little nook area there. So the index, if it's not written, that means the index is 2. They won't write that in there, just like you wouldn't write a 1 in front of x, you would just write x. So the 1's implied in front of the x. Also the 2, if it's not written, is implied in that little index there. So if you're going to add or subtract radicals, you need the same index, and you also need the same radicand, the A and D on the end. And a radicand is just the number underneath. So if you had something like the square root of, we'll say the 3 square root of 2 plus 5 square root of 2, you could add both of those because one, the indexes are the same. Both indexes are 2 since they're not written. And then the radicand is 2 in both of these. And so you just put the numbers in front together. 5 and 3 makes 8 square root of 2. So we'll go through a few examples like this. Example number 1, add or subtract, simplify by collecting like radical terms if possible. So we got 3 cube root of 2. Here the index is a 3. Minus the square root of 6 plus 6 cube root of 2 plus 2 square root of 6. So need the same index if we're going to add radicals and the same radicand. So we've got 3 cube root of 2 and 2, or 6 cube root of 2. So those are like terms. Also we've got square root of 6 and 2 square root of 6. Those are like terms. So just going to put the numbers in front together. We've got 3 and 6. That gives us 9 cube root of 2. And then also the negative square root of 6 and the positive 2 square root of 6. One thing that you'll want to remember here, because we're putting the 2 with the number that's in front of this square root of 6, and that is actually negative 1. So 2 and negative 1 is positive 1 square root of 6. And when you've got a 1 in front of a radical, you just leave it off. Third example, we've got 13 square root of 72 plus 6 square root of 72. So right off the bat, we've got two terms that are like terms, square root of 72, square root of 72. You can put those numbers in front together so that we get 19 square root of 72. On this one, we'll want to go a little bit further. We're going to simplify the radical part because 72 has a square in it. So look for squares to simplify. So again, list the squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64. So you're looking for one of these that might go into 72, and you can test that out just by dividing it. 72 divided by, let's say, 49, that doesn't work out. 72 divided by 36, and if you do that in your calculator, you get 2. So what we're going to do to simplify this is we're going to rewrite the 72 part. So this is going to be 19. And then since 72 can be written with a square, we're going to rewrite it as 36 times 2. The square root of 36 times 2. And then I'm going to put a line through the 36 because the square root of 36 is actually something we know. And the square root of 36 is 6, so I'm going to put that on the outside and multiply it by 19. So now we've got 114 square root of, and the only thing left inside that square root is 2. Third example, add, simplify by collecting radical terms if possible. So here, no like terms right off the bat. We don't have another cube root of 625, and the cube root of 135 doesn't have anything any like term to go with it. But in this case, we can simplify. I'll underline that. In this case, we're going to look for cubes. And the reason for that is because they're cube roots. So the list of cube roots again, or cubes again, 1 cubed, 1 times 1 times 1, 2 cubed, 2 times 2 times 2, 3 cubed, 4 cubed, 5 cubed, you could do 6 cubed, 7 cubed. You'll probably want to have a list like this available just to reference while you're working on section 6.4. So we're looking for cubes. We're going to simplify these. So 625, if you divide it by 343, that doesn't work. If you divide it by 216, that doesn't work. If you divide it by 125, and I'll do that here. So 625 divided by 125. In that case, you get 5. So we can rewrite that 625 as 125 times 5. Okay, and don't forget your 3 there in that nook. So 2 cube root of 125 times 5. I'm going to do the same thing with this cube root of 135. Going to check to see if any of these cubes go into 135. So you might do 135 divided by, let's say, 64. That doesn't work out. 135, and we'll go up the list, divided by 27. And in that case, you would get 5. So 135 divided by 27 equals 5. So we can rewrite this 135 inside that cube root as 27 times 5. Okay, so done with all that scratch stuff. I'm going to put a line through the things that are cubes. The 125, the 27. Cube root of 125 here on the left is 5. So I'm going to take the cube root of 125 and multiply that by the 2. Cube root of 27 is 3, so I'm going to multiply the outside by 3. And in front of that radical, there's just a 1, so it's 1 times 3. Okay, so now we've got 2 times 5, which is 10. Cube root of only a 5 left on the inside. And then we had basically 1 times 3, which is 3. And cube root of just a 5 left on the inside. So at the beginning, it looked like these were 2 radicals that we couldn't add, but now we've got cube root of 5 and cube root of 5, which means that these are like terms now. We just have to put the numbers in front together, 10 and 3. So 13 cube root of 5. Fourth example, multiplying square root of 10 times this binomial. And just like we typically do when we have something like 2 and then a parentheses x minus 3, you got something butted up against the parentheses, that means you're multiplying times all the things in there. And we're going to do the same thing with the square root of 10. So taking it times both those terms on the inside, square root of 10 times 2 is 2 square root of 10. And then square root of 10 times 10 square root of 10. So we've basically got a 1 on the outside. That's the number we're going to multiply by the 10. And then the square root of 10 part and the square root of 10 part, square root of 100. We can multiply those radical parts. And then next up, the square root of 25, you guys probably know, is just 5. The square root of 4 is just 2. The square root of 100, like we've got here, is just 10. So in reality, This part, this square root of 100, is just 10. So we've got negative 10 times 10. So we've got 2 square root of 10. We don't know what the square root of 10 is. But 10 times 10 is 100. And at this point, these are not like terms, so we cannot add them. This is as far as we can go. Next up, fifth example. This is our last example. Multiply, assume that no radicands were formed by raising negative numbers to even powers. We've multiplied binomials before, this 2 terms in the first parentheses, 2 terms in the second parentheses. And remember that you want to distribute that first term to both of those terms, and then also the second term we're going to distribute to both terms in the second parentheses. 8 times 8, that's easy enough. 8 times negative square root of 2. In the middle, we've got square root of 2 times 8. That's going to be positive 8 square root of 2. And then square root of 2 times negative square root of 2. That's going to be negative. Since they're both square roots, we can multiply them. Square root of 4. So a couple things happen here. We've got negative 8 square root of 2 and positive 8 square root of 2. Those two become 0. They just cancel each other out, negative and positive. And then also this square root of 4. We talked about that before. Square root of 4 is just 2. So basically we're left with 64 minus 2, or 62.